This is a truth table for the 2-to-1 multiplexer. Here is a NOT gate or an inverter created in Circuit Lab, and you could see the output is opposite of the input. This is an OR gate created in Circuit Lab, and you could see that only one of the inputs is required to be high in order for the output to also be high. This is an AND gate created in Circuit Lab, and you could see that both inputs need to be high in order for the output to be high. Here is a 2-to-1 multiplexer created in Circuit Lab. There are two AND gates, a NOT gate, and an OR gate, and you could see the relationship between this multiplexer. When the S input is low, in order for the output to be high, A needs to be high, and vice versa. When S is high, B needs to be high for the output to be high. Here's a 2-to-1 multiplexer created in Tinkercad, and you could see the blue wire represents input B, the yellow wire represents input A, and the green wire represents input S. When S is low, you could see in order for the LED to turn on, input A needs to be high, and now you'll see once input S is put to the high, in order for the LED to turn on, input B must also be high. Here is a hand drawing of a 4-to-1 multiplexer with 3 2-to-1 multiplexers. This is my 2-to-1 multiplexer. Currently the S, A, and B are all connected to ground, and you could see the LED will turn on when there's a high output. So with S and ground, if you move the B to positive, the light stays off, but when you move the A to positive, the light turns on, and when you move the B back to ground, the light stays on. I'm going to put everything back into ground. Now you move the S into high, it stays off. When you move the B to high, it turns on. When you move the A to high, it stays on. Moving the B to ground, the LED turns off. This is the same 2-to-1 multiplexer with the LED, but now with the Arduino code. When the S input is in the positive position,